talked about polynomials, which are the graphs, but not just quadratics. So anything that has an exponent of anything is considered a polynomial. And what we're going to be focusing on now is factoring these polynomials. And there's several different methods of factoring we're going to do. The purpose of that is, one, to find x-intercepts, like we do with quadratics. That's the big thing that we're going to do. So the first thing we're going to look at is the GCF. You will always, in every question you do, look to see if there's a GCF. There may be, there may not be. So when we're looking for a GCF, we're looking for what the terms have in common. What can you divide both of those terms by? So on number 1, we have 12x cubed plus 10x squared. What is the largest number that goes into both 12 and 10? 2. 2 is the only number other than 1. Okay, so we have a 2. And then if you have the x's, how many do they have in common? 2. X squared. I can take an x squared from both terms. Okay, so that's the GCF. We want to write what's left over. So when I take the 12 and I divide out the 2, I have 6. And then I had x cubed, but I took out 2 of them. So that just leaves 1x. Plus, then if I take out the 2 from the 10, I have what? 5, because we're dividing. And then x squared, if I divide out x squared, those basically cancel. So we have a GCF of 2x squared, and then we have 6x plus 5. So if I wanted to find the x-intercepts, I would set this equal to 0 and get 0. And then if I could set this one equal to 0, and I would get negative 5/6. That would be GCFs. So number 2, what's the GCF between 14 and 7? 7. And then how many x's? 2. So I can take out x squared. It's always going to be the smaller of the 2 exponents. Okay, and so that if I divide out 14 divided by 7, I'm left with divided by 2. And then if I divide out or cancel out 2 of the x's, I'm left with x to the 6th minus what? 1. Because 7x squared, if I divided out the whole 7x squared, that's 1. What's the GCF between 30 and 10? 10. And then I have x to the 2nd. And then what about y's? Just y. Yep. Okay, and that leaves me with 3. And then I have 1x. The y is completely canceled. So just 3x plus the 10's cancel, the x squared's cancel, but I have y to the 6th left over. Or you could put 1y to the 6th. And then number 4, what's the GCF? We have to look at all 3 of them. So what goes into 20, 56, and 32? 4. Okay. And then x, do I need an exponent? No, because the smallest one is just an x. What about y's? Just a y, because this first one is only y. So you, basically whatever the smallest exponent is, that's what's going to be the one that goes with your GCF. And so then I'm left with 5x, right, plus 14. The x is canceled, but I have y squared minus, what's 32 divided by 4? 8. I have x to the 4th and then y. There you go. So are there any questions on that part? We've kind of done this before, so hopefully you remembered enough. Okay. Now the next thing are difference of squares. So we can factor a difference of squares when, what does difference mean? Subtraction. Whenever we have a subtraction sign and we have two perfect squares on either side of the subtraction. This is a way we can factor. It's kind of like a shortcut. In order to be a perfect square, if it's a variable, the exponent must be divisible by 2. So any variable with an even exponent is considered a perfect square. So let's go over here on the side and just list out some perfect squares, just to help us. 2 squared is, next one, 4 squared, 5 squared, next, next, yep, keep going, yep, 100, good. So if I say, what's the square root of 100, you would say 10. Because 10 times 10 is 100. That's what makes it a perfect square. That's how you do square roots. So if it's a variable, you don't take the square root of the exponent. You actually divide the exponent by 2. So if I say, what is the square root of x squared, it's just x, or x to the first. Because x times x is x squared. So the square root of x to the 10th would be x to the 5th. Because x to the 5th times x to the 5th is x to the 10th. Those are your exponent rules we talked about. So what would be the square root of x to the 16th? X to the 8th. A lot of people see that 16 and they put 4 because the square root of 16 is 4. But when it's an exponent, you divide by 2. And so what would be the square root of x to the 38th? X to the 19th. Good. So in order to factor using the difference of squares method, again, it has to be a subtraction sign. And you have to have perfect squares on either side for it to work. So let's say that I have a squared minus b squared. That's what my problem is. I have something squared minus something squared. When I factor this, I'm going to have two factors, two sets of parentheses. In the first one, it's going to be a plus b, and the second is going to be a minus b. So let's go to number 5. 49 minus x squared. So we have to get our a and b by taking the square root. So to go from a squared to a, you take the square root. So what is the square root of 49? 7. So my a is 7. Your a always comes from the first one. Okay. Then we're going to take the square root of this one. Just ignore the minus. B is the square root of x squared, which is what? X. So I can factor this 7 plus x, 7 minus x. So if I wanted to check my work, if I do 49 minus x squared, I get that number. 7 plus x, 7 minus x. Yep, those are the same thing, just different ways of writing. It's like a dollar bill versus 4 quarters. Same value, just a little different. And you have to keep, the order matters. Because 7 minus x is not the same thing as x minus 7. 2 minus 5 is not the same thing as 5 minus 2. So the order does matter. Okay. Number 6. Now also, we are supposed to be looking for a GCF. Is there anything that you can divide x to the 10th and 100 by? This one doesn't have a number, that one doesn't have an x, so no. There's not a GCF. So my A, I'm going to take the square root of x to the 10th, which is what? X to the 5th. And for my B, I'm going to take the square root of 100, which is just 10. 10. So when I factor this, I have x to the 5th plus 10, x to the 5th minus 10. That's your answer. Number 7, look for a GCF. Those are totally different letters, so there is no GCF. So for my A, I'm going to take the square root of 9x to the 6th. So it would be 3 x to the 3rd. Yep, you take the square root kind of separately. And then my B, I take the square root of y to the 16th, which is y to the 8th. So 3x cubed plus y to the 8th. 3x cubed minus y to the 8th. Number 8. When I see these numbers, I know that 32 is not a perfect square. So I'm guessing there probably is a GCF. Is there anything I can divide both of those terms by? 2. If I take out a 2, I'm left with x squared minus 16. Because that 2 went in the front, and 32 divided by 2 is 16. And so then I can do my difference of squares with what's left in parentheses. And the 2, I will bring that down, and that will be a part of my final answer. So my A is going to be the square root of x squared, which is x, and B is the square root of 16, which is 4. So my final answer has the 2 in the front, that GCF you have to bring down, and then x plus 4, x minus 4. Are there any questions? Okay. Number 9. I see numbers that are not perfect squares, so I know there has to be a GCF for this to work. So what can you divide 7 and 28 by? 7. Do they have anything else in common? They both have an x. So that's going to leave us with x to the 6th minus What? 4. Just 4, yep. See if you can go from there. So my A is coming from this x to the 6th. When I take the square root of that, I get x cubed. And then my B is the square root of 4, which is 2. So then in your final answer, you have to include the GCF that we found, which was 7x. And then x cubed plus 2, x cubed minus 2. Any questions on that? Okay. Let's do number 10. What can you divide 8 and 18 by? 2. And if you think, if you're dividing them both by 2, are you getting perfect squares? Yeah. Okay. Then x's. How many x's can I bring out? Only x cubed, only 3. And then y's, this first term doesn't have any y's, so we can't bring any of those out. So this leaves me with, what's 8 divided by 2? 4. And then how many x's? So x squared minus 9 y squared. Good. Because all of the x's came forward. And then my A is the square root of 4x squared, which is what? 2x. And B is the square root of 9y squared, which is 3y. Good. Oh, I didn't make that orange. Then for your final answer, bring down your GCF. And then I have 2x plus 3y, 2x minus 3y. And we're going to stop there for today.